I want to talk to you about something that sounds completely crazy at first. People are going to say cold doesn't exist. You're going to think I've lost my mind. You walk outside in the winter, your fingers go numb, your nose turns red, you're shivering like crazy, and someone's going to tell you that cold doesn't exist. That's nonsense, right? But here's the thing, in physics, we have to be very careful about what we mean when we use words. And when I say cold doesn't exist, I'm not playing word games with you. I'm telling you something fundamental about the nature of reality, about how the universe actually works at the most basic level. Let me start with a question. What is cold? Think about it for a second. When you touch an ice cube, what exactly is happening? Most people would say the ice cube is giving you cold. It's transferring coldness into your finger. That sounds reasonable. That's what it feels like. But that's not what's happening at all, not even close. What's actually happening is that heat is flowing out of your finger into the ice cube. The ice cube isn't giving you anything. It's taking something away from you. It's stealing your heat. Now you might say, okay, fine, but that's just semantics. Whether cold flows in or heat flows out, I still feel cold, so cold still exists. But no, this is not semantics. This is the difference between understanding the universe and just making up stories about it. And here's why it matters. Heat is a real physical thing. It's energy. It's the motion of atoms and molecules. Cold, on the other hand, is just the absence of that motion. It's like darkness. Darkness doesn't exist as a thing. Darkness is just what we call it when there's no light. You can't have a darkness generator that shoots out darkness beams. That's ridiculous. You can only have something that blocks light or removes light. Same thing with cold. You can't have a cold generator in the fundamental sense. You can only have something that removes heat. Now let me tell you what heat really is, because this is where it gets beautiful. Everything around you, every single thing, this table, that chair, the air you're breathing, me, you, everything is made of atoms and molecules. And these atoms and molecules are not sitting still. They're jiggling, they're vibrating, they're bouncing around like crazy. Even in a solid piece of metal that looks perfectly still, the atoms inside are vibrating back and forth thousands of billions of times per second. In a gas like air, the molecules are flying around, smashing into each other, bouncing off the walls, zooming all over the place at hundreds of meters per second. Temperature is just a measure of how fast these atoms and molecules are moving on average. When something is hot, it means the atoms are jiggling really fast. When something is cold, it means the atoms are jiggling slowly. That's it. That's all temperature is. It's not some mysterious fluid that flows from place to place. It's just atomic motion, and heat is the energy of that motion. So when you touch something cold, like that ice cube I mentioned, what's really happening is this. The molecules in your finger are jiggling fast because your body is warm, about 37 degrees Celsius. The molecules in the ice cube are jiggling much slower because ice is cold, around 0 degrees or below. When your finger touches the ice, the fast-moving molecules in your skin start bumping into the slow-moving molecules in the ice. And when a fast-moving thing bumps into a slow-moving thing, the fast thing slows down and the slow thing speeds up. It's like billiard balls. If you hit a moving ball into a stationary ball, the moving ball slows down and the stationary ball starts moving. So energy transfers from your warm finger to the cold ice. Your finger molecules slow down, which means your finger gets colder. The ice molecules speed up, which means the ice gets warmer and eventually melts. But notice what's happening here. The thing that's moving, the thing that's being transferred is heat. It's energy. It's the kinetic energy of molecular motion. Nothing is flowing from the ice to your finger. The ice isn't doing anything to you except sitting there being slow and sluggish and accepting your energy. Now here's where people get confused. They say, okay, but I feel cold. I experience cold. Surely that means cold exists. But what you're feeling is not cold entering your body. What you're feeling is heat leaving your body. Your nerve endings detect the temperature drop. They detect that your skin is getting colder because it's losing energy. Your brain interprets that as the sensation of cold. But the sensation is caused by heat loss, not by cold gain. It's like if you're in a boat and water is flowing out of the boat through a hole. You feel the boat sinking. You might say you're experiencing sinking. But sinking isn't a thing. Sinking is just what happens when water leaves and nothing replaces it. Same with cold. Cold is just what happens when heat leaves and nothing replaces it. Let me give you another example to make this crystal clear. Imagine you have a tank of water and you want to make it colder. How do you do it? Well, you could put it in a refrigerator. But what does the refrigerator actually do? Does it inject cold into the water? No. The refrigerator is a heat pump. It sucks heat out of the water and dumps it outside the refrigerator into your kitchen. That's why the back of your refrigerator is warm. It's not creating cold inside. It's removing heat from inside and putting it outside. The cold inside is just the absence of the heat that used to be there. Or think about air conditioning. Same thing. The air conditioner isn't cooling your room by blowing cold air into it. It's removing heat from the air in your room and dumping that heat outside. That's why there's a big hot exhaust unit outside your building. All the heat from inside is being pumped outside. The coolness you feel inside is just the absence of that heat. Now let's go deeper. Let's talk about absolute zero. This is the coldest possible temperature. It's minus 273.15 degrees Celsius, or zero on the Kelvin scale. And here's the amazing thing. Absolute zero is not just really, really cold. It's the point at which all atomic motion stops. At absolute zero, the atoms and molecules have no kinetic energy left. They're not jiggling at all. They're completely still, or as still as quantum mechanics allows them to be, but that's another story. Now think about what this means. If cold were a real thing, if it were some kind of substance or energy that you could add to something to make it colder, then there would be no limit to how cold you could make something. You could just keep adding more and more cold. But that's not how it works. There's a limit, absolute zero. And that limit exists because what we're really doing when we make something colder is taking away heat. And you can only take away so much. Once you've removed all the heat, once the atoms have stopped moving, you can't go any further. There's nothing left to remove. It's like emptying a bucket of water. You can keep pouring water out until the bucket is empty, but once it's empty, you can't make it emptier. There's no such thing as negative water in the bucket. Same with temperature. Once you've removed all the kinetic energy, you're at absolute zero. You can't remove more than all of it. And here's another beautiful consequence of this understanding. Heat always flows from hot to cold, never the other way around. Why? Because energy naturally spreads out. Fast-moving molecules bump into slow-moving molecules and share their energy. The fast ones slow down, the slow ones speed up, and eventually everything reaches the same temperature. That's equilibrium. But you never see the opposite happen spontaneously. You never see slow molecules spontaneously speed up, while fast molecules slow down even more. That would violate the second law of thermodynamics, which says that entropy always increases in a closed system. And what is entropy? Entropy is a measure of disorder, of how spread out the energy is. When all the energy is concentrated in one hot spot, that's low entropy, that's organized. When the energy is spread out evenly everywhere, that's high entropy, that's disorganized. Nature always moves from low entropy to high entropy, from organized to disorganized. That's why heat flows from hot to cold. It's the universe spreading out energy, increasing entropy, moving toward equilibrium. So when you put an ice cube in a warm drink, the heat flows from the drink to the ice cube. The drink cools down, the ice melts and warms up, and eventually they reach the same temperature. But the ice cube never makes the drink colder by sending out cold rays or cold particles. It makes the drink colder by accepting heat from the drink. The ice is just a low-energy sink that heat flows into. Now I want to address something that might be bothering you. You might be thinking, okay, fine. In physics, we say heat is the thing that moves, and cold is just the absence of heat. But language is flexible. People say it's cold outside. They say the wind is cold. They say cold water. Why are you being so pedantic about it? Can't cold just be a useful word that means low temperature? And yes, of course, in everyday language, cold is a perfectly fine word. I use it myself. I say it's cold outside. I'm not going to walk around saying it's characterized by a relative absence of thermal energy outside. That would be ridiculous. Language is for communication, and if everyone understands what you mean by cold, then it's a good word. But here's the thing. When we're doing physics, when we're trying to understand how the universe actually works, we have to be precise. We have to distinguish between our sensations and descriptions, which are useful but sometimes misleading, and the underlying physical reality. And the underlying physical reality is that there is only one thing moving around, only one form of energy being transferred, and that's heat. Cold is not a substance. It's not a form of energy. It's not a thing that exists independently. It's a description of a state of low thermal energy. It's the same reason we don't say that health is the absence of disease and disease is a real thing, so therefore health doesn't exist. No, both health and disease are descriptions of states. But when we're doing biology or medicine, we focus on the mechanisms of disease, on the bacteria and viruses and genetic mutations, because those are the active agents, the things that cause change. Health is just what you have when those agents aren't present or aren't active. Similarly, in thermodynamics, heat is the active agent, the thing that flows and causes change. Cold is just what you have when heat isn't present. Let me tell you about one of the most amazing experiments that demonstrates this. Scientists have gotten incredibly close to absolute zero, within a fraction of a degree. They use something called laser cooling. Now you might think, how can a laser cool something? Lasers are hot, right? They burn things. But it's not about the laser being hot or cold. It's about using the laser to remove kinetic energy from atoms. Here's how it works. Atoms can absorb light, but only light of very specific frequencies. When an atom absorbs a photon of light, it gets a little kick, a little push. Now, if you shine a laser at an atom from one direction, and the atom is moving toward the laser, the atom will absorb photons, and each absorption will slow it down a tiny bit. It's like throwing tennis balls at a truck that's driving towards you. Each tennis ball that hits the truck slows it down a little. But atoms are moving in all directions, right? So you shine lasers from all 6 directions, up, down, left, right, forward, backward. And you tune the lasers so that atoms only absorb photons when they're moving toward the laser, this way. No matter which direction an atom is moving, there's a laser opposing its motion, slowing it down. The atoms get slower and slower. Their kinetic energy decreases. The temperature drops. And scientists have used this technique to cool atoms down to less than a millionth of a degree above absolute zero. Now notice what they're doing. They're not adding cold. They're not injecting some kind of cold substance. They're removing kinetic energy. They're taking heat away using a very clever trick with light. The cold that results is simply the absence of the heat they've removed. And at these incredibly low temperatures, bizarre things happen. Quantum mechanical effects that are usually invisible at normal temperatures become obvious. You get things like Bose-Einstein condensates, where thousands of atoms all fall into the same quantum state and start behaving like one giant atom. You get superfluids that flow without friction. You get all kinds of weird and wonderful phenomena. But all of it happens not because you've added cold, but because you've removed heat, because you've slowed the atoms down so much that their quantum nature takes over. Now let's talk about the philosophical side of this, because I think it's important. The fact that cold doesn't exist as a thing tells us something deep about the nature of reality. It tells us that our sensations and our language don't always map directly onto physical reality. We feel cold. We have a sensation we call cold. But that sensation is caused by heat leaving our body, not by cold entering it. Our brains are not directly perceiving the fundamental physics. They're interpreting changes in our body state and giving us a sensation that helps us survive. And that's fine. That's how evolution works. Evolution doesn't care about teaching you physics. Evolution cares about keeping you alive. So your brain gives you a sensation of cold when you're losing heat too fast, because that's dangerous. You need to find warmth or you'll die. The sensation is useful, but it's not a direct perception of reality. It's an interpretation, a model your brain creates. This is true for so many things. Color doesn't exist in the world. There's no red or blue out there in reality. There are just electromagnetic waves of different frequencies. Your eyes detect those frequencies, and your brain creates the sensation of color. Sound doesn't exist in the world. There are just pressure waves in the air. Your ears detect those waves, and your brain creates the sensation of sound. Sweetness doesn't exist in the world. There are just molecules with certain shapes. Your tongue detects those shapes, and your brain creates the sensation of sweetness. And cold doesn't exist in the world. There is just the kinetic energy of atoms and molecules. Your skin detects when that energy is being drained away, and your brain creates the sensation of cold. But the underlying reality is just heat, just energy in motion. Now, here's the thing I really want you to understand. This is not a trick. This is not me playing with words or being difficult. This is a genuine insight into how the universe works, and it matters. It matters for engineering. When you design a refrigerator or an air conditioner or a heat engine, you have to understand that you're moving heat around, not moving cold around. You have to understand the flow of energy. It matters for science. When you study thermodynamics or statistical mechanics or condensed matter physics, the whole framework is built on the idea that temperature is molecular motion and heat is energy transfer. There is no place in the equations for cold as a substance. And it matters for understanding the world. Once you see that cold is just the absence of heat, you start to see other things more clearly too. You see that darkness is just the absence of light. You see that silence is just the absence of sound. You see that vacuum is just the absence of matter. You see that many of the things we think of as positive things, as things that exist, are actually just absences, just gaps, just the lack of something else. And that's not diminishing them. That's not saying they're not real or not important. The absence of something can be just as important as the presence of something. The silence between notes is what makes music music. The empty space between atoms is what makes matter mostly empty and allows chemistry to happen. The darkness of night is what allows us to see the stars. Absences matter, but they're not things. They're the lack of things. So when I say cold doesn't exist, I'm not denying your experience. I'm not saying you're wrong to feel cold or to say it's cold outside. I'm saying that the underlying physical reality is different from our everyday descriptions. There is only heat. There is only the kinetic energy of atoms and molecules. Temperature is the measure of that energy. And cold is just what we call it when that energy is low or when it's being drained away from us. And once you understand that, once you really get it, the whole subject of thermodynamics becomes clearer. You understand why heat engines work the way they do. You understand why refrigerators need to dump heat outside. You understand why absolute zero is the ultimate limit. You understand why the second law of thermodynamics is so powerful and universal. It all comes from this one simple idea that there is only heat, only energy and motion, and everything else is just a consequence of how that energy moves and spreads and changes form. So the next time you're cold, the next time you're shivering in the winter wind, remember what's really happening. Your body heat is being stolen by the cold air. The air isn't giving you cold, it's taking your heat. The molecules in the air are moving slower than the molecules in your skin, so energy flows from you to the air. You're a heat source. The world is a heat sink. And the sensation you feel, that uncomfortable, unpleasant sensation of being cold, that's your body's way of telling you, hey, you're losing energy too fast, get somewhere warm before you run out. But there's no cold out there attacking you. There's just the absence of heat. There's just the low energy state of the air molecules. And understanding that, really understanding that, that's what physics is all about. It's about looking past our sensations and our language and our intuitions and seeing what's really there, seeing the universe as it actually is, not as it appears to be. And when you do that, when you see the world that way, it's beautiful. It's simpler and stranger and more wonderful than you ever imagined.